Throughout history, countless myths and scientific theories have attempted to explain the universe's origins. How did it all begin? Why is there something rather than nothing? These questions date back to the dawn of language itself and remain just as important today as they were in ancient times. Many scientists and philosophers have ventured their own explanations. Yet so far, no one has provided a truly definitive answer. It's honest and perfectly acceptable to admit, I don't know. The more appropriate question might be, what started it, rather than who started it? Since who implies a human-like entity. If we don't know, we should simply say so. Some people, however, cannot live with uncertainty. Consider those who see a strange light in the sky and label it a UFO. Not only do they acknowledge that it's unidentified, but they leap straight to the conclusion that it must be intelligent aliens. But that logic doesn't hold up. Admitting ignorance is the first step toward honest inquiry. In his accessible and engaging work, physicist Lawrence Krauss reminds us that nothing isn't necessarily the absence of everything. Rather, what we traditionally think of as nothing can be quite complex. Darkness, not light, might actually be the greater mystery. According to Krauss, concepts like nothing and something have challenged thinkers for millennia, yet modern science has radically transformed the conversation. Once we believed that empty space truly contained nothing at all. Now we know that even what seems like a complete void can be teeming with quantum activity. Modern physics reveals that empty space isn't empty. Even if you remove all particles and radiation, quantum mechanics and relativity tell us that so-called empty space is a roiling sea of virtual particles flickering in and out of existence too quickly to observe directly. Though we can't see them, we can measure their effects. In fact, these effects allow us to make scientific predictions accurate to 9 decimal places, unmatched precision in any area of science. Such discoveries force us to rethink the nature of nothingness. This new understanding feeds into our current best explanation for the universe's origin, the Big Bang Theory. While not everyone agrees that it explains why there is something rather than nothing, it's widely regarded as our most robust model. In the early 20th century, breakthroughs in physics and cosmology paved the way for the Big Bang concept. Stephen Hawking, one of the greatest theoretical physicists of our time, described how the universe began from a point called a singularity. As we trace the cosmos backward in time, conditions become so extreme that our usual understanding of physics breaks down. The Big Bang Theory asserts that our local universe burst into existence approximately 13.7 billion years ago. It rests on 2 key assumptions. First, that Einstein's theory of general relativity correctly describes how gravity works on all matter, and second, that on a large scale, the universe looks the same in every direction, no edges, no preferred points. This uniformity suggests that the Big Bang wasn't an explosion from a single point, but rather a simultaneous appearance of space-time everywhere. Still, what existed before this moment? Scientists have yet to determine what happened before Planck time, the earliest period we can meaningfully discuss. Einstein's relativity suggests that at the very beginning, all 4 fundamental forces, strong nuclear, weak nuclear, electromagnetic, and gravitational, might have merged into one. Stephen Hawking argued that asking what came before the Big Bang is meaningless, since time itself began at that moment. There's no before any more than there's a point south of the South Pole. Hawking's no-boundary proposal implies that the universe has no definitive starting point. Before the Big Bang, space-time may have behaved in such a way that time as we understand it simply didn't exist. Yet he also maintained that the universe hasn't existed forever. Rather, time and the universe had a beginning in the Big Bang, just with no initial boundaries. A universe from nothing, as Krauss puts it, offers an accessible look at recent ideas and discoveries, about how the cosmos might have arisen. The question, how does something come from nothing, remains one of the greatest mysteries. According to Hawking, because there's a law like gravity, the universe can spontaneously create itself from nothing. Krauss suggests that it's plausible the universe could have come from a deeper form of nothingness, a state without space or time, and may one day return to nothing. This notion might sound miraculous, but quantum mechanics shows us that empty space can spontaneously produce particles without violating energy conservation. Initially, you have zero total energy, just empty space. And later you have particles with equal but opposite energies summing to zero. Thus, nothing can become something quite naturally. If you add gravity to the mix, allowing for positive and negative energy, entire universes can emerge spontaneously. While we can't yet prove that our universe was born this way, the fact that it's plausible is astonishing. These revelations challenge our intuitive sense of what nothing means. Space itself can be dynamic, bending, expanding, and perhaps appearing out of nowhere. It's even conceivable that universes can pop into existence from absolute nothingness, no time, no space, no matter, no energy, only the laws of physics. Though we're far from certain, the fact that such scenarios can be described and explored scientifically is remarkable.